So what we'll do is put on the graph grid the ordered pairs -2, -10, and so on down the line. So let's do that. -2, -10, that means we have to have an x-axis and a y-axis. I'll draw my arrows for the positive directions and label these. X for the horizontal, Y for the vertical. Then -2, -10 means we start at the origin and count 2 to the left, and then down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -2, -10. -2, -10. The next ordered pair is -1, -7. Starting at the origin, I count to the left 1, down 7. 1, 2, 3, 4, 5, 6, 7. And there's the point, -1, -7. Next I have 0, -4. This means we start at the origin, go 0 horizontally, and down 4 vertically. 1, 2, 3, 4. And so here's the point, 0, -4. Then 1, -1, that means I start at the origin and count 1 to the right and 1 down. And so here's the point, 1, -1. And then 2, 2. Start at the origin, count 2 to the right and 2 up. And this gives me 2, 2. Now, I chose 5 different x values to find the y values and get ordered pairs to put on the graph. The numbers I chose for x were numbers that are easy to use. I did not choose fractions, I did not choose decimals, I did not choose very large numbers or very small numbers, that is, down in the negatives. I chose numbers that are easy to work with. But the equation y equals 3x minus 4 works for many, many x values. In fact, I cannot think of any x value for which it will not work. If x is a fraction, like 1/2, I could substitute 1/2 in place of x, that will work. And so on with all the rest. Fractions, decimals, large positive, very small negative, any number I choose for x will give me a y value to pair up with it. You notice that the dots that I have on the graph for these 5 points all lie on a line. If I put my ruler down, I can make the ruler go through all of these dots. In fact, if I graph every point that satisfies this equation, all of the points that satisfy the equation will be on this line. And so I can draw the line all the way across my picture, all the way across. I can put arrow points on both ends of it to indicate that it doesn't stop where my picture stops, but goes on forever and ever. And what I have now is a picture that represents all of the solutions of the equation y equals 3x minus 4. So the equation y equals 3x minus 4, let me get it up here. The equation y equals 3x minus 4 has a graph that shows as a line. Every linear equation has this feature. Let me give you a statement about linear equations that says exactly that. The graph of a linear equation in 2 variables is a straight line. This is a very, very important statement. It is vital that you understand that this statement is true. Let me put a star beside it. The graph of a linear equation in 2 variables is a straight line. The graph of a linear equation in 2 variables is a straight line. Another pair of sentences that will help you with your graphing. Follow. One of them is the fact from geometry that says 2 points determine a line. 2 points determine a line. Think about that. If I put 2 points on this sheet of paper, no graph grid now, just the 2 points. 1 point alone, I can't put the ruler down in such a way that I know where the line goes. There's no way to tell. If I put a second point and I make the ruler go through both of those, there's only one line that does so. That one. 2 points determine a line. This means that in our algebra, we must have 2 ordered pairs, 2 ordered pair solutions to be able to draw the line. However, use at least one more point as a check. Use at least one more point as a check. If the first point was a correct ordered pair solution and the second point wasn't, I would draw the line and be perfectly happy. How would a third point help to be a check? Let's take another look at a quick little sketch. Let's say one point is here, another point is here, and when I find a third point, I find that the third point is here. What about that? Can I draw a line that goes through all 3 of these? Of course not. So that means that something was wrong. It may have been that this point was wrong and the line really should be here. It may be that this point was wrong and the line really should be here. But one more point will tell me that something is wrong if they do not line up. 2 points determine a line, but use at least one more point as a check. As we graph linear equations, that's exactly what I'm going to do. I'm going to find the 2 points and then one more. That is, I'll use 3 points in graphing a linear equation.